Hello all, this is Dr. Fox. Let me introduce you to the heart. In this video, I'll discuss the functions and locations of the four chambers of the heart with basic terminology regarding the cardiac cycle, valve function, and heart sounds. The heart is an extraordinarily important organ to the body and especially to the cardiovascular system. It's an ever-working pump that forces blood through the vessels out to the metabolically active tissues. It's one of the first organs to become fully functional in utero, and it works until the day a person dies. On average, the heart is between 200 to 300 grams and is approximately the size of a person's loosely closed fist. The heart lives within the thoracic cavity, more specifically within the mediastinum of the thoracic cavity, and then most specifically within the middle mediastinum of the thoracic cavity. The middle mediastinum is defined by the boundaries of the pericardium, which is the sac that contains the heart. Over here we can see that the pericardium has been incised and reflected away largely. The epicardium still remains upon the heart, and we get an anterior view of the heart. Now, drawing a line down the middle or the midline of this particular individual, we can see that 2/3 of the mass of the heart is going to reside on the left side of the midline, and 1/3 will reside on the right side of the midline. The human heart is a four-chambered organ. There are 2 atria which receive blood and 2 ventricles which distribute blood. Let's start our tour with the right atrium. The right atrium receives 3 sources of blood. One from the superior vena cava, which is the main venous conduit from regions superior to the diaphragm. The other from the inferior vena cava, which is the main venous conduit from regions inferior to the diaphragm. There's also the coronary sinus, which is the main conduit of blood draining the myocardium. There's also a left atrium, which receives blood from 4 pulmonary veins. These pulmonary veins drain the lungs of richly oxygenated blood. From the atria, blood passes through atrioventricular valves on the way into the ventricles. On the right side, there is a tricuspid valve, because there are 3 cusps, and on the left side there is a bicuspid valve because there are 2 cusps. 3 versus 2. Once through the atrioventricular valves, blood is then in the ventricles. The ventricles are going to supply different circulatory routes with blood. The right ventricle is going to supply blood out to the pulmonary loop for gas exchange. So that blood will, and this isn't shown here, but the blood will be pushed out a pulmonary valve to a pulmonary trunk that divides into 2 main pulmonary arteries, which go out to each lung. The pulmonary valve is named for the vessel that it serves. So pulmonary valve serves the pulmonary trunk. Let me erase this. On the left side, from the left ventricle, blood is forced out the semilunar aortic valve, or just the aortic valve, into the ascending aorta. So again, with respect to the semilunar valves, which get their names from their cusps, they are ultimately named for the vessels that they serve. Now, this is a very simplified cardiac cycle. You will encounter a much more sophisticated one when you discuss cardiac physiology, but this is anatomy, and so we'll go with a very parsimonious model here. The movement of most materials within the body is going to be pressure driven, and that's no exception for blood. And so blood is going to largely abide by Boyle's law. So if we dig back into high school physics, we'll remember that pressure times volume equals a constant. To rearrange that mathematically, we see that pressure and volume are inversely proportional. The larger the volume, the lesser the pressure. The smaller the volume, the greater the pressure. And so the heart is going to go through different stages of relaxation and contraction. And that's going to affect pressure inside the heart and therefore the flow of blood. So let's begin with diastole. Diastole comes from a Greek word meaning to expand or expansion. And what happens here is that the myocardium of the atria and ventricles relaxes. And as a result, the heart dilates. It expands, and then pressure within the ventricles specifically are going to draw blood through the atria and into the ventricles. At the end of diastole, about 3/4 of what we would call end diastolic volume of blood, that's the amount of blood that's going to be within the ventricles whenever the ventricle is done with its relaxation. This percentage is going to vary in accordance with physical activity. At rest, it's probably going to be greater. During activity, it may actually be less. So we go from this stage of diastole, where most blood is just rushing into the ventricles, to a period of atrial systole. Systole comes from a Greek word systole, meaning to contract. And here the atria contract. This is what's known as the atrial kick. And so they'll squeeze whatever remaining blood is within them into the ventricles. At rest, this may be a lesser amount. During physical activity, this may be an even greater amount. From atrial systole, we go to ventricular systole. Ventricular systole is what people are referring to when they say systole, or when they're taking a systolic measurement. It's during this time that the ventricles contract. And when the ventricles contract, these atrioventricular valves are going to close, and blood is going to flow through the semilunar valves out to both the pulmonary and systemic loops via the pulmonary trunk and the aorta, respectively. So let's take a look at what these valves are doing during different stages of the cardiac cycle. So for your bearings, this is anterior, this is posterior. The anterior-most valve is the pulmonary valve, and then we have the aortic valve, and then to the right here we have the tricuspid valve, and to the left we have the bicuspid valve. So these are the semilunar valves, and these are the atrioventricular valves. During systole, the pulmonary and aortic valves are wide open. Interventricular pressure is pushing that blood through the valves. During diastole, what happens is pressure is greater in the pulmonary trunk and aorta, and so blood will actually begin to move back toward the ventricles, but it gets caught in these cusps. And that pressure forces these cusps closed or in close approximation with one another. So during diastole, the pulmonary and aortic valves are going to be closed. During that same event, during diastole, the atrioventricular valves will be wide open because we know that that's when most of the ventricular filling is occurring. And during systole, those atrioventricular valves will be closed because we need the forward movement of blood out to the pulmonary and systemic loops. Now, there are heart sounds that one can auscultate or listen to. You probably are used to thinking of it in terms of the lub-dub. That lub sound is what we would call S1. The dub sound is S2. Here we can see these sounds, S1 and S2. These are the sounds of blood turbulence as valves are closing. And let's take a look at this graph to see what corresponds to this. So red is aortic pressure, green is ventricular pressure, and yellow here, maize or gold, is atrial pressure. And really it's this green curve here that we want to pay attention to, because ventricular pressure is what's going to really affect the closing of atrioventricular valves, the opening of semilunar valves, and then the closing of semilunar valves. So, as the atrioventricular valves close when ventricular pressure begins to increase, there's going to be blood turbulence as it pushes against those cusps that are held in place by the chordae tendineae that we'll discuss in a subsequent video. That sound is audible as S1 or lub. The next audible sound is going to be blood turbulence as the semilunar valves close. And the semilunar valves are going to close at the beginning of diastole, right? As the heart is relaxing, blood is going to be pulled back to bring those cusps into approximation, and there will be turbulence, and we'll hear the S2 or dub sound. So those are the sounds that we can hear when the heart is working. There are other sounds. There's S3, sometimes S4, sometimes other murmurs to be heard, but these are just the basics. So we've introduced you to the four-chambered heart, the vessels that communicate with these chambers, the valves which are associated with these chambers, and how blood moves and the sound that it generates as it moves. This is your summary slide. Thank you very much for your time.